All right, in this video, we're going to look at finding the equation of a line. So this really focuses on 4F of the textbook if you're interested in that. But it is good to also know the theory behind the line, y equals mx plus c. So we generally use this formula to find the equation of a line. Now, it's important to remember that m is the gradient or slope, same thing. C is your y-intercept. So you can see here in our equation, m, which is the number in front of the x, and c, the number by itself, are your gradient and your y-intercept. Now, this is only true if your equation was in this form, okay? It must be in y equals. If you have it in another form, don't think that just the number in front of the x is going to be your gradient, because it's not. All right, so let's just recap what the gradient actually is. So the gradient tells you how much the y variable either increases or decreases as the x variable increases by 1. Okay, so let's just say, for example, Darren gets paid $40 per hour. As the hours increase by 40, and I've just realized I haven't fixed up this error. Let me just quickly fix that. Okay, so I just fixed that. So Darren gets paid $40 per hour. So that means for every hour, every time the x increases by 1, his y variable, so in this case, the amount he gets paid, is increasing by $40. If we were doing that as a rule, that would be P equals 40t. Now, if we go back up and have a look at our general equation, y equals mx plus c, now there is no y and there is no x, but when we have a context for a problem, we don't use x and y. We use things that represent the context. So in this case, P is representing the pay, how much he's paid, and t represents time. Okay, so the number in front of t is 40, which represents the gradient. Now, the second example, a 1,000 litre tank is being emptied at a rate of 30 litres per minute. Okay, so first of all, if something is being emptied, it's going down. Okay, so we're starting at 1,000 and it's going down 30 litres per minute. That means if it's going down, your gradient is going to be negative. So the rule that models the volume of water in the tank is V equals negative 30t. Okay, so the negative 30 relates to the gradient, and plus 1,000. So this 1,000 is just how much we start off with. So if we go back to our rule, the negative 30 represents m, your gradient, and 1,000 represents c, your y-intercept. And when you think about the graph, we're starting at 1,000 and we're going down. So just focusing on the gradient for now though, the gradient of this rule, for example 2, is 30. So for every minute, okay, so for every minute, the volume of the tank decreases by 30, so 30 litres. Okay, so remember also that we don't use x and y, we're using t to represent the x variable and v to represent the y variable, because we have a context. Now, here's the rule for the gradient, okay, which I've shown you before, but it's a good idea to have that in your notebook. All right, so if the question doesn't tell you what the gradient is, so in the previous two examples we had a context, you can actually calculate it just using 2 points. So these 2 points we label x1, y1 and x2, y2. Now we use x and y because that's how we state coordinates, and the 1 just represents the first point and the 2 represents the second point. So, which I've just got written there. These 2 points can either be given to you or you can read them from the graph. Okay, so the first example we're going to look at one where they're given to you. So we've got the point 2,5 and the other point is negative 1,14. So what we would do first of all is label the points. So you can see 2,5 there, and I would label that x1, y1. So I'll just write down how I would label it. And I don't think my pen is going to work. Oh, yes. Okay, so we've got 2,5 Now you could use a different color. I would use a different color just because it's, easier to see. Label it X1, Y1, just so we don't get confused when we're doing the substitution. When you get used to this, you might not have to label it anymore, but just because it's new stuff to you, it's a good idea to label them. So there's X2 and there's Y2. Okay, so remember X, Y, X, Y. And here is our formula. Okay, so always write the formula. The reason for that is if you don't, it's not going to stick to memory. So while you're learning, try to write it out. And then it's substituting in. So Y2 first, which is 14. Okay, so you can see here the 14 minus Y1, which in this case is 5. X2 is -1, so you can see the -1 there. And X1 is 2, so we've got -2. So then we just simplify that. So we've got 9 over -3 equals -3. So the gradient going through those 2 points is -3. All right, looking at the next example. Okay, so we can also do it from a graph. Here we've got 2 points. Okay, so you could use your formula if you liked, or you can just count them. So this point up here goes to y equals 10. This point here starts at 0. So we're going from 0 to 10 for our rise. So you can see down here, I've written 10 for our rise. And then going across for our run, we're going from 0 across to 2. And that little diagram has moved, I apologize. So 10 over 2, so your gradient is 5. But you would also get the same answer if you use the formula. Now, if we were writing this as an equation, now this one's a bit of a unique one because it's going through the origin there. So that means our y-intercept is 0. So our equation is just y equals 5x. So remember, the number in front of the x is your gradient, and we don't write plus 0. Okay, so we're just going to write it as y equals 5x. All right, so let's get into how to do the equation. So first of all, it's important to understand the y-intercept. So up to this point, you've calculated the y-intercept by letting x equal 0. But if you're doing an equation, it's important that you can find the y-intercept using the rule y equals mx plus c. Okay, so the y-intercept, just to recap, is where the line crosses the y-axis. So this is where x equals 0. Okay, so sometimes you have to work out what it is, you let x equal 0, or sometimes in the context of a problem, we call it the initial value. So in the examples above, Darren's initial pay was 0. Okay, so that was his y-intercept. His initial pay was 0, he hadn't yet been paid. And the tank example, the initial value of the tank, the volume of the tank, was 1,000. Okay, so that was your initial value before it started getting emptied. So you can see here in example 3, I've just used the same thing. Okay, so your initial value is 1,000. All right. Now, finding the linear equation in the form y equals mx plus c. So there are really 2 ways you could go about it. So I'm going to show you this way first of all, and in the future I will show you the other way. This rule here allows us to substitute in the gradient, so you can see there m, and another point on the line. So a point on the line, sorry. So you could use x1, y1. You could use x2, y2. It doesn't matter that x1 and y1 is written there. Whatever you put in is going to work, as long as it's a point on the line. Now, the x and the y, they stay as is. Okay, so we're not substituting anything for x and y. We're only substituting in for y1, m, and x1. All right, so for example 4, we're going to find the equation of the line passing through 1, 3, and 5, 11. So before we start using this equation, we must first of all find the gradient, because we haven't been given the gradient, we've only been given 2 points. So that's what the working out here is. Okay, so similar to before, I've used this formula, I've substituted my points in, and I've simplified to get a gradient of 2. Now I use this new rule. So y minus y1 equals m times x minus x1. So I substitute in the point 1, 3. So that means y1 is 3, x1 is 1, and my gradient is 2. So I've got y minus 3 equals 2 times x minus 1. And then what I've done in this next step is I've just expanded the bracket and then I've simplified. So my final equation is y equals 2x plus 1. So from this equation, I can see my gradient is 2 and my y-intercept is 1. All right, so let's just have a look here, and I might have to make that smaller so we can actually see our graph. That might be too small for us. Let's make it bigger. Sorry, I don't want to make it too hard to see. Okay, so let's find the equation. So the first thing is to find your gradient. Now you can write your formula first. So y2 minus y1 over x2 minus x1. Now remember to label your points. So we've got x1, y1, x2, y2. Okay, and we're just going to substitute in those values. And I'm just going to change my color of my pen. Okay, so y2 is 8, y1 is 4, x2 is negative 2, and x1 is negative 1. Okay, so don't get mixed up with your negative. We've got a minus there, but we've also got a negative 1. So 8 minus 4 is 4, and negative 2 plus 1 is 1. So your gradient is equal to 4. Finding your equation. So first of all, write the rule. Y minus y1 equals m x minus x1. Okay, so substituting in a point, remember you could use either one, but because we're just learning, let's just stick to x1, y1. So we've got y minus, and then I'm going to put in y1, which is 4. M is also 4. And then x minus x1. Whoops, didn't work too well. So I've got y minus 4 equals 4x. 2 negatives gives you a positive, so that's just going to become plus 4. Whoops, I've made a mistake somewhere along the line. Okay, so I've just realized where I went wrong. So this should have been a negative, and that makes that a negative. Sorry about that. Hopefully you picked that up. Okay, so that's the problem when you're recording. I don't want to stop the video to stop the video and then figure out where I went wrong. Okay, let's just quickly get rid of this. Go away. So, oh no, I was right with that anyway. Okay, let me just quickly fix things up. So that's got to be a negative 4. This is still x. So negative 4x and then minus 4. Okay, good. All right, let's solve now. We want to get y equals. Okay, so to get y equals, we've got to get rid of this 4 by adding 4 to both sides. And then we add 4 to this side. So that disappears. So we're left with y equals negative 4x. And then we've got negative 4 plus 4, which is 0. Now we don't really write plus 0, so our equation is just y equals negative 4x. But I wanted to write that there because remember, our equation in the form y equals mx plus c, c is our y-intercept. So for our next column, the y-intercept is 0, 0. Okay, so you could write it as a set of coordinates, or you can say it's at y equals 0. All right, so when we're graphing this, and I'll just scroll over, hopefully I can scroll over, there we go. When we graph this, we just need 2 points. So one point is the origin. Okay, so we can use this point here. And another point is just anything on the line. So the other point that we had was -1, 4. So if we just find that -1, 4, which is down here. Okay, and then you just draw a straight line going through that. Now, this is going to be fun. Oh, that's a pretty good line. Okay, so you would use a ruler, but because I'm on the computer, it's pretty difficult to use a ruler. All right, so let's go and do the next one. Okay, so I'm going to just change my pen to write my rule down for the gradient. So y2 minus y1 over x2 minus x1. And I'm going to label these points y2, oops, not y2, sorry. Why did I do that? x1, y1, and x2, y2. Okay, and now let's substitute in. So y2 is 12, y1 is 4, okay, x2 is 2, and x1 is -2. So we've got minus, -2. 12 minus 4 is 8, and here we've got 2 plus 2 is 4. So our gradient is 2. All right, now let's do our rule. So I'm going to write that down first. So y minus y1 equals m x minus x1. And we're just going to substitute everything in. So I've got y minus y1, which is 4. And our gradient is 2. And we've got x minus x1, which is -2. So y minus 4, let's just expand this bracket. So 2 times x is 2x. Terrible x. And then this is a positive. I just want to make sure I didn't get shouldn't be a negative like I did before. 2 times 2 is 4. And then let's add 4 to both sides to get rid of this one here. And I'm left with y equals 2x plus 8. So here's my equation. I can see my gradient is 2 and my y-intercept is 8. So in this column here, my y-intercept, if I was writing it as coordinates, is 0, 8. Now the 0, because your y-intercept is always at x equals 0, so you could write it like that, or you can say your y-intercept is at y equals 8. All right, so let's graph that. Okay, so, sorry, let's just go over a bit more. Okay, so when we're graphing, another way we can graph is we've already got 3 points. Okay, so we've got the y-intercept and the 2 points that we got at the start. So there's our y-intercept, but sometimes it's a good idea to graph using the y-intercept and the x-intercept. So if I wanted to know the x-intercept, you've done this before, we let y equal 0. So I'm just going to let y equal 0 here. 0 equals 2x plus 8. So let's just subtract 8 from both sides. That disappears. So we've got 2x equals -8. Divide both sides by 2. So x equals -4. So your x-intercept is at -4, which is here. Now, just to make sure, we can plot another point, okay, just to make sure we're correct. So another point was -2, 4. So -2, 4, which is here, and that looks like a pretty good straight line. Okay, so if it wasn't all on the same line, I've made a mistake somewhere along the line, but looks good to me. All right, because this video is getting too long, I'm going to stop there, but have a go at doing the last 2 on your own. Well done.